die demonstration by going into the die design wizard. Here I'm just picking the geometry, the part that I'm going to work with, looking at the different names of the project that will go on the folder that stores all the part files in. Here you can see the geometry on my screen. This is the part. It's a pretty straightforward cover. It's got a big flange going around it, and then other areas that need to be unfolded. To get more information about the part, I'll jump over into the measurement tool. This quickly gives me my overall X, Y, and Z size. It'll give me density. It'll give me mass, basically the cubic volumes, all those sorts of things. Wanting to get a little further understanding of the part, let's look at the angles of those flanges. The dialog box shows that the colors are set so that purple is straight up and down vertical. Anything curved back under itself would appear in red. The tooltip shows me exactly what the angle is at any given point. I'm also very concerned with the radiuses. I want to make sure that they're generous enough to make good forming conditions. I might be concerned with what the smallest radius is, and you can see it's just a matter of setting color ranges to what we prefer to see. And that tooltip again, you see everything as far as what each radius is. Lastly, we want to see if there's a uniform wall thickness. So here we'll see if there's anything discolored. It would be either thicker or thinner. And again, a color range can be established to what we desire. With the tooltip showing us exactly what each area looks like. There's a nice dynamic sectioning tool also to show us at any given point something that maybe we have concerns with. We see an area that's thinner. Is it being coined? Is it just drawn incorrectly? We get the answers to those questions very quickly. Well, with that, we've got a pretty good understanding of what the part looks like and what it's going to do. So we understand some of the requirements now that we need to deal with to unfold it, form it in a strip. So let's begin working with the part. Here I'm simply giving it the next station a name. The idea here is if I wanted to, I could set my distance, not necessarily the progressive distance of the strip. Also, if I wanted to mirror this, I could to create right hand, left hand for a 2 out in that sort of situation. Let's now work with this particular part, and we want to establish if we're going to work with the die side or the punch side. My preference is the die side, and as we take the inner die side walls, it also measures the thickness, the gauge thickness of the material. That is now stored within our setup, where we can also select the material we're going to work with. Within the library here, you see there's an extensive array of different materials. We can easily add more materials. It's just a matter of knowing what the specific properties are. And we can set the overall progressive distance between when we start laying out the strip. It's going to keep track of the overall strip width and length as we build it. Now, seeing that diagram, we're setting the distance that the punch will travel through the steel on shaping it and cutting it, and then we're setting up the clearance now for each of those components that you see on that diagram. You know, some of these are going to be a simple slug drop like going through a shoe. Others we're going to do a shear, so we'll put in the 10-12% you would expect. Others like the die backing plate, we're not going to have a hole. The punch holder plate, that's going to just basically be the retainer, so we'll put in what our slip fit condition is. Now we're selecting the type of die steel we want. Typically we see straight land, 1/4 inch with a few degrees of relief. So that's our preference. That's the way we want to design the die. Let's save that and set up. Now that information is our go-to information throughout this project. Let's start with our first forming shape. Typically you might see this particular outer flange hit in a couple of different stations. Instead of taking the bend all at once, we might try to break it into a couple, maybe set one at 45 degrees, and then take it to final form. So we're going to create what's called a binder, or a face that's going to come off at an angle, here at 45 degrees. If you're not happy with some of the surface conditions I see, you have a nice smoothing tool, or a patch tool we like to call it, that interrogates the part and says, well, we can do a little better job here. Let's smooth across those areas to get that binder that we want. It's got a good look to it as far as my angle, but I also want to extend the length out. I also want to make it a bit bigger, so I have plenty of distance to catch the flange. There you can see it's extended out off the end, so if there's any shape to that, it's got a face to land on. That's what we're calling a binder, or binder faces. And you're going to see the flange will be bound to it as we execute this function called blank on binder. That's what we're developing too. That's the flange we're developing now, shown in red. We'll go ahead and let that calculate. Some of the things we can look at as we do this, though, include other forming conditions. Maybe I've got a pressure pad I want to incorporate. I may have a part that's using draw beads on a binder. That information can be included because it's going to affect the way that part gets formed. Now you see it developed to our 45 degrees. That's looking good. That would be the intermediate shape before we take it to final form. Is it formable? We'll quickly take it through our analysis tools to look at any area where we maybe develop some strain. Is there a wrinkle condition? Is there possibly a tear condition? Also, we can set this up so that we can look at some spring back. I'm picking a few areas. I'm saying hold on to that and let's see what possible areas of spring back may develop. It's based upon just that hit, just that development to 45 degrees. And there you saw in red an area that may show some spring back on the edge. We can take that information much further and actually doing the forming tool as well and adapting it to compensate for the spring back as well. Well, with that, now let's take this all the way to its form before we would have hit that at 45 degrees. We want to develop it to the top faces of the part, like you see here. So we'll select that as our forming shape. Again, use the same material properties as before, and tell the system to blank out to that shape or those series of surfaces, like you see here. So yes, we can blank to flat, but it's good to know we can blank to anything we can model. We can blank to anything that faces off of the part itself. And again, you can see how station to station now, we can go down the line and look at formability and see if we're doing something that perhaps is creating a difficulties for us. All right, with that, let's go a little further here in doing our forming. Let's look at the end now, where we've got those straight linear bends. That's a simple 90-degree bend, so we'll use our unfold function for that. All right. Basically, we pick the flat face we're developing to, pick the radius we're developing, and then our choice again, do we want to set that at an angle as we play with the radius? Do we want to move it? Do we want to make it bigger? Maybe we'll hit that at 45 degrees too with a bigger radius, and then come back and final form it. That way we can push on that radius and get rid of some spring back. In this case, we'll take it straight out to flat, and there you see it very quickly develop that. With that, we'll go ahead with our next forming station. As you can see, we're kind of just like working in what we call like a notebook. We get an idea, we'll take it in that direction and take a look at it. Is it what we want? Yes. If so, then we'll proceed. If not, go back, go off in a different direction. So there's no set rules on which way you go about doing it. It's just whatever makes sense as far as the process that you developed. Looking at this folded tab, let's develop that out to flat, and as we do so, let's capture where that rolled edge is. We want to put that in its position as if it were formed before this bend occurred. So we'll calculate it, and there you see as that is laid flat, the rolled edge where that pierce is now in the position planar to where it would have been before the fold. So a very nice and handy piece of functionality found in local blank. We use local blank again, and this time let's take the rest of that formed area to flat. So again, we create another forming station so that we have that information that we can put in a die strip later. Simply selecting where the flat is, using save material properties, let it do the calculating for us. Gone are the days of having to cut sections and take measurements and all that difficult stuff, tedious stuff. See, another form we need to take, we want to get the shape of that punch that would go into the strip before the folding or the rolled edge occurs. So basically we'll lay that out flat now. Pretty simple, straightforward function. Again, just go to local blank, we'll pick that rolled up edge, and let it calculate. Now we get an idea of what the preliminary punch would look like before trying to punch that rolled up edge. So now it's laid out to flat. With that, we need to get the perimeter, so we'll calculate that using blank, and this is pretty straightforward. It's basically just gathering the outer edge so that we have the shape that we need of the blank for nesting, like you see here. It's a very handy function. It takes everything we have on the part and lays it out to a flat. So what we could have done is back here at the very beginning, maybe for quoting purposes, we wanted to get an idea of what the blank would have looked like. Simply go back to where we began. We'll calculate the blank at this point and let it establish the 2D perimeter. Maybe I need to know the overall perimeter for knowing my laser time if I'm going to cut it on the laser. An idea of what my footprint looks like, for a blanking die. And it's always interesting to compare the result of a one hit, which is what we just did, which would be like putting my foot on it, pushing it out uniformly, to this progressive blank that we did here at the end of our progressions. You can compare the two by overlaying it. You can see there's a little shift in distance, but pretty much the shape, the size is consistent. So for doing this for quoting purposes, you have no problem knowing that the quote is fairly accurate. With the forming done, let's now go into the actual strip design. We'll take the information that we've learned here in the different forming stations and use that to build the strip. Simply now I'm going to switch over to my wizard that's designed just for strip design. And now we'll use our blank part so that we can do our nesting. Now I'm going to do a 2 out in this case, 2 of the same part. Again, we could have done right hand, left hand had I mirrored some of the forms that I needed. As I build up this layout for the nesting, you can see I'm going to keep track of the scrap and all the other information on screen. Here I'm setting up the distance, what I want it to look like as far as distance between the parts, between the stations. Do a second row, do I want it rotated at 180 degrees? So pretty much you have full control over how you would want to rotate and orient the part in the nesting. It'll give you what your scrap and everything is as you do it. Now maybe here just playing with it so you can see a few things. Perhaps try to force it to shift so that it intertwines like you see here. An attempt at that might be to keep the coil width narrower. Here we're going to set it up so that we have our different stations opposed to one another. So I'll either decide on the actual distance in between, or maybe I want to change the overall width so that that's the coil that I would order, whatever the preference is. So it's important to know there's lots of easy to use tools for setting up the nesting. Now I'm looking at the number of stations I want, whether it be the individual stations here where I have things set for my punch area, or down the road where I want more stations for putting in forms. So all this can be edited to later. At any time I can go back, change the number of stations, change the distance in between, whatever my preference is. Do I want to work left to right, right to left? Again, I can set that here as part of my preference. What I'm doing now is establishing my carrier. So we'll just add a few references as we build up the carrier. And also what I'm doing is establishing where I want my punches to go. Generally it's like the same operation at one time. So just a few references so that I can build up the web of the carrier, which you'll see just simply dragging across here using my sketcher. As I work with the sketcher, you're going to see lines flashing vertically and horizontally. That's telling me when things are constrained. Maybe it's found something it's parallel to or perpendicular to. We'll throw some dimensions in. Here is the carrier strip, and then you can see the webbing that's going to actually hold the part. From here I may want to establish where my pilot is going to go. Place it right there. We'll give that a dimension. So that'll be the diameter of the pilot. Everything is editable. You can quickly change things on the fly or come back later and make that change. Quick location dimension to establish where that's at. As the sketch is finished, you might say, it turns that pink color. If it's blue, that means it's not constrained, not dimensioned. Maybe I need to get a webbing out here to establish what that punch shape is in between my stations. And now I've got some areas to deal with that are out here off the edge. So maybe I want to create a punch that's going to come out into the material guide area. Maybe something like that. Of course, I'd oppose it on the other side. This being a 2 out of the same part, I could easily build across, creating something symmetrical in the sketch. Typically, you might individually build them like this if they're right hand, left hand, just because of minute differences that may be there in the right or left hand. Not all right hand, left hand parts are truly right hand, left hand. So whichever the preference is, particularly whatever the case is involved per each job. So again, further dimensions to show me where my punches are going to break. You notice I'm not really concerned about everything being exactly perfect. I'm not going back and trimming up overlaps in my sketch where punches occur. I'll just close that area off on both sides. That's where I'll stop those punches. That would be like the seam or the break point between those two punches. I'm doing just a simple line because I've got nice tools for creating the overlaps. Alright, so maybe something like that. Alright, to establish all the different punches that I'm going to need. With that, we'll focus then on the simpler ones. It makes sense that the very first thing I would put into my strip would be my pilot punch. Select the pilot, select the location, where do I want it to go. The first hit's going to occur here at the end, and then it carries on down the strip. There you see all the holes for that punch. And all the punches are going to work that way. It's simply a matter of picking what I want to punch, then selecting its first location, and accepting it. And here we've got a number of these simple, small, round punches that will knock out fairly quickly. You notice a green surface is left behind as we build these punches, these punch areas. That green surface, in this case, I'm going to use to locate and establish the diameter of these punches. These punches are going to come from a catalog. So just as I might order something from my Dayton provider for Dayton punches, I'm going to go ahead and order the same way here in my catalogs. I could use other catalogs too. It's whatever we come up with. Our list of catalogs is growing more and more extensive too, as our users need more and more catalogs. Here I'm focusing on the EDM, wire EDM punches. Now, those are pretty straightforward because I had the shape. Now I'm going after these other ones in the middle, perhaps between the two stations. And as I build this, I want to put some conditions on it. I want to put some rounds on these corners. Alright, so it's just a matter of selecting where, putting it in there. That now gives me that perimeter that I need. Now we'll go ahead and we'll punch that. Where do I want it to occur? Where I initially built it? No, maybe a next station over. So you've got full control over where you want it to go, plus you can always go back and make the edits that you need. Alright. Now, perhaps now we'll go and do the other side and do the same thing. We put the radiuses on the four corners right there at the carrier, as you see here. So now that will affect the shape of the punch and also the hole that it gets punched into. Set that up to oppose the previous punch. There it punches it, carries it on down the strip. Right. Now with these wire EDM punches, those green faces I'm going to use to actually create the 3D geometry of the punch. If you notice as I pick, I'm picking inside an area and establishes the perimeter, and then I pick outside of it, even though there's no face underneath it because this is going to go into the material guide area, it still allows me to pick that perimeter. So it's a very intuitive tool. Now in this case I picked that edge, but what I want to do is establish a distance around it. So I'm going to extend that edge, and the idea behind this is I want to create an overlap. That way the punch on one edge will shear off the other edge. Alright, so now I know I'm going to clean up that outer distance along the outside of the coil. Right. That looks good. That's what we want to punch. And you can see here in the punch display that the overlap is there. That's exactly what I want. We'll go ahead and position it. And that's done. Now you see how it's carried on down the strip as well. Again, in picking the punch area, notice I pick inside a zone, it captures it, then I pick in an adjacent zone and it stretches it out further. So a very intuitive tool to help me build this up. That's why when I sketch, I'm not worried about everything being absolutely perfect. Now we'll go ahead to the cookie function and we'll build that extended edge around. That is what we want. Looks good. We'll go ahead now and punch that side. I'm just pretty much working my way down the wizard to create each of these different punches. Alright, we got a couple more to do. We need to get the area inside. Alright, right there. Again, I want to put radiuses on that. So pick the particular corners where we need those radiuses. Alright, now where do we want that to go? Let's find an area where it's got enough distance. That looks good. Again, if designing you find that they're too close together, we can go back and we can relocate where that punch occurs. Finally, again, putting radiuses on the opposite side. The same punch could be used and simply rotate it over on the opposite side. That we could do inside of Tool Design if we wanted to. This shows you what it would look like to build the strip with all the information shown for quoting purposes, also for layout purposes, tooling review purposes. Now we'll get that area in between the last punch, and I'm just going to pick that zone because I want to create my overlaps a different way. Here on the advanced function, if I pick the end, you notice it does this little cookie cutter. So when I have punches next to one another, I can eliminate that shear corner, like you see here. So it's a handy tool. It's fully dynamic. You can change it however you want. In this case, I'm simply going to extend that out. We can play with the radius. I can change the offset. I can change the distance. That's how I can establish the overlap I have between my punches. Now that's built. Looks good to me. Go ahead and punch that out. That'll occur down here at the end of the punch series. Very simple, very straightforward. Finally, we have the other side to do. Capture that area. We already know the type of extension we want, so we'll go to the cookie function. It knows what we did last time we used it, so it's going to input the same values. Go ahead and punch that down at the end. As you see here. And so very quickly we've established all our punches, and you can see how the strip is being formed. With that, all we have left to do now are to bring the forming shapes in. That's simply a matter of picking the form and then positioning where we want it to go on the strip. So however I developed those forms, it's not like I had to follow any specific order. It's not like I couldn't change my mind and go back and do something different. Right? But here I'm logically placing them in the progression of order of operations that would occur in my strip. Now we'll get those last few forms in. I can pick off of the form itself, or if I need to, I can pick right off of the strip. Right, here you see I just copied that over to the opposite side. Now I've got my 45-degree flange. Changes the color in the forming station so that I know I've used it. And then again, I don't have to follow the order. Maybe I want to put the last one in now. And that looks good. That would be my final form. And then, well, I'd need an idle in there. So let's go back and pick that 45-degree flange. Give us some distance between those last two stations. Alright, so very quickly we've built our strip. We've got all our forms in place. We have all our punches in place. We know the overall size, the shapes involved, everything. And let's do a few zoom ups so you can see all the detail has been captured now in our strip and each of the different punches. So with that, we have that established. We have all the information we need to take this on over into our die design. A nice piece of functionality we have is to look now at all the different forms and punches and see what the overall pressures are. So here I just adjusted it to tons. We can zoom up on each one of those punches, and this gives us an idea of what it's actually going to take to stamp this strip. And this is a very handy tool of finding out what the die tip is and making sure that there's a good balance from left to right, end to end. So now we're ready to go into our tool design wizard. So I'll just switch over to that particular wizard. And let's go and get a die set. Now this is our first glimpse at what we have inside of the catalogs. The catalogs can be catalogs that would come from a supplier like you see here, your Danley and Dayton catalogs, your Missimi catalogs. This is an ongoing list all the time as we're having more and more catalogs being added to it. Some of these are custom for just our specific needs of a customer or things that can be shared. Also, you see we have different components. We could have assemblies as catalogs, a rocker assembly, a cam pierce unit, in this case a die set. So the entire die set is going to be loaded here through our catalog. It's just a matter now of having the configuration the way we want it. So it would be the way you do your dies. Everybody may have dies that they do a little differently. I'm going to tell it that I just simply want to position this particular die set right here at the beginning edge of the strip. And as it loads, it sizes itself per the strip. Alright, so the die steel width that you see is established by the width of the strip. And then from there, the rest of the components are sized based upon simple rules. Like there's a gap between my material guide and my stripper, and that stripper plate is big enough to cover the width of the strip. Likewise, distance away that establishes the overall size of the die. You notice here I'm using a formula to establish the overall length, which I gather here back in our setup. Pull downs can be created in a setup to establish the different thicknesses that we commonly use per each plate. As I make changes, here I'm changing the length of one of the die steels, and as it updates, you notice that other things linked to it update. So if I'm going to change the length of the die steel, it makes sense I change the length of the material guide. If I change the length of the retainer plate from punch retainer, then I'd also change the length of the stripper plate. So these simple common rules can be established and used throughout the setup, making things a lot easier to adjust, very customizable. The use of rules, use of pull downs, automatic rounding up, rounding down. Also, we have the ability to pull our sizes directly from a catalog. So perhaps if I put in my Danley bushings, I can go right to that catalog size and adjust it as I need to. Well, with that, we've adjusted the size of our steels that you see here. And now I'm just going to turn the punch off, and you can see the strip lying nicely on top of the die steel. Right. So what we're going to do now are pull all the punches. And like I said before, you can use the punch geometry and mirror it, rotate it 180 degrees if it's going to be used again and again. That's fine. But for what we're doing here and to illustrate this functionality, we'll use all those punches that we have on the strip, and in one operation we'll create these punches and all the holes that they sit in. So focusing here on the wire EDM punches. As I accept this, it begins to preview and build them for me. Alright, so we'll turn the whole die set on. There you can see how it's extended now past the coil steel, so it shows me what my shear distance is going to be through that coil. Alright, and as we build this, it'll build the pockets that it sits in on the punch side and also the clearances on the die side. Now originally, when we set up those clearances, the stock material guides were not there. So now let's establish what we want to cut around those. and then make any final adjustments that we need. All right. So as I highlight each of the different plates, you can see them highlight on the screen. All right. So it's all linked together, very intuitive, very fast and powerful. And now it goes ahead and builds the punches. It builds the holes that the punches sit in as well, both in the punch and the die side of the tool. A little bit hard to see, but it's there. Let's do a little dynamic clipping plane here, and we'll try to cut that so that we can land on one of those punches. And you can see the clearance now for the slug drop going through the die shoe. You can see on the die steel the land, and then the 2 degrees of relief, and then you can see the fit in the punch retainer. So all that's done in one operation. All those punches can be edited together or individually, in your case. If I know that the punch on the right and the left are the same, I can detail one, but I've got all the holes I need in all the plates, which is an important thing. Alright, looking at the strip, you can see we got a forming area or two. Let's concentrate on one of these forming areas. With that, we'll go back into our catalog, and I'm going to pick here just a assembly. It has the screws and dowels already placed in my die steel, so I'm placing more than one component at a time, which is very handy. And like I said, those units could be punch units, they could be cam pierce units, rocker assemblies, it's whatever you want to assemble together. We'll position that steel to capture that particular station, and I'm going to tell it that I want to grab the information that I've got here right off the strip. So I'm working on the die side, creating a piece of die steel that's going to form that station for me. A lot on the screen, so let's just open up that individual component now. Everything is still there, I'm just looking at one part. Makes it much more easier to work with. Alright. Blanking off the steel, we can work with what we're going to cut it back by. Here I'm just going to simplify my shape a bit. Alright, so we don't need those faces surrounding us. And what we'll do is now extend this outer edge all the way around like you see here. So I capture that edge, use my extension tool, something plenty big enough that will get out past the outside of my block. Now let's do along this other edge. We'll simply chain from side to side. You notice there's a little notch left in there. As I sweep that face out, which is basically like a big ruled face, you notice it doesn't care about the notch. So I just simply make it big enough that the notch is off the side of the block, it becomes irrelevant. And you even see it do that with the areas that are undercut, if you can imagine that. So basically it's giving me a flat, planar face as my solution. Now we'll simply take the block and trim it back by those extended faces. Alright. Pick which side of the block I want to keep. You notice I didn't close the inside, so it doesn't have to be perfect airtight. I do want to close that because that's part of my form, but nothing keeps me from proceeding if things aren't done in any set particular order. It's up to me to do it how I want to do it. And with that, let's show some of the tools we have for closing up these little gap areas. Maybe I want to grab that edge and say I want to blend across to the other side. And it's such a powerful function that keeps things tangent to tangent. It knows the flow, it works with the flow of the face. Again, we'll do the opposite side. Alright, I will tell the system, let's stitch those together. I've got the 3 holes left, 2 on the side, 1 in the middle. And let's use a nice tool called Close Open Gaps. We just simply pick or box pick the areas that we want to close. It's more than one face in each of those holes. And it goes and puts in its solution as quickly as it can. So that particular form area is now closed. I save it, and when I do that, it bounces me back out to my assembly. Alright, there you see that now we have a little bit of work to do, because with the cut, those screws are not in the right position, and frankly they don't look to me like they're big enough. So let's do a quick edit here. We'll edit the screw parameters. Let's make it bigger while we're at it. So it's just a matter of going into the catalog, Selecting the size, selecting the length we want, like you see here. Say that looks good, and you'll notice that quickly on the screen it's changed. Let's now drop that in. We'll recess it a little deeper. You can recess things based upon rules. Here I'm just dropping it in so that I know it's deep enough within the steel. Now as we calculate it, you'll see it also updates the hole that sits in it. So there you see the counterbore on the opposite side has been drilled and tapped. Let's flip over down to the other side and give our attention to the punch and talk a little bit more about the catalogs. Here in this particular case, I want to use the catalogs to put my pilot punches in. So those are going to sit in the retainer plate. I'll simply hop on over into our catalog. There I'm picking just a straightforward pilot punch. To do a little bit more work so you can see how easy it is to edit this. Of course, with the pilots, you're picking your diameter, your body diameter, the overall length, and then the p-value. So all that is established based upon whatever type of catalog you're using. Here I'm using a TIPCO catalog. Could just as well be a Dayton catalog, you name it. Alright, so we're working off the back of our retainer plate, and I'm using the locations right off of the strip. So that's where the first one went. That's the next one, and on down the line. Alright, so do I like the length? Do I like the positioning? Well, I can see that my shoulder's coming up into the strip. So let's go back, do another quick edit here on the fly. Maybe in this case I'm going to change the length a little bit. Alright, so we select a shorter length, and also while I'm at it, maybe I want to put a little bit of clearance on that p-value so that the pilot slips in and out fairly easily. Alright, that looks better. We'll cut it as we build it so it knows the hole that it sits in as well, as you see by the counterbore.